Hi everybody, we're about to start a new topic called differentiation. Now, when you're asked to differentiate something with respect to x, that means you're finding a formula for dy by dx. So the moment you see this terminology here, dy by dx, that means you're differentiating. Now, the something that you could be differentiating could be a curve, y, or just simply an expression. However, before you differentiate any curve or expression, you need to make sure that it has no roots, no brackets, and no x's on the denominator. That's really important. You can't differentiate until you've got rid of roots, you've got rid of brackets, and you've got x's off the denominator. That's really important. Now, how do you actually differentiate? Well, you multiply each term by its power of x, and then you subtract 1 from this power. That's really important there, the order. So to differentiate, you multiply each term by its power of x, and then you subtract 1 from the power. So let's look at our example 1 here, part A. So it asks us to differentiate with respect to x, and then it gives us a curve. So I've copied the curve down, curve y. Before we differentiate it, we need to do our checks. Does this curve have any roots in it? The answer is no. There's no roots. Does it have any brackets? No, there's no brackets in it. Does it have any x's that are on the denominator or the bottom line? The answer is no. So that's great news. That means we're ready to differentiate. So to signal our intent that we're going to differentiate, we now write dy by dx down. So the moment you see dy by dx on your page or anywhere, that means you're beginning to differentiate. Okay, copy down your equals. So to differentiate, we're going to differentiate each term separately. So let's go to the first term, 5x cubed. In order to differentiate it, you have to multiply that term by the power of x. The power of x is 3. So we're going to multiply this term by 3, and that's going to give us 15. And then copy x down. And now subtract 1 from the power. So the power is now just going to be 2. Do you see that? So you multiply the term by the power of x first. We get 15. Copy x down. And then subtract 1 from the power. Okay, let's repeat for the next term. So again, the next term is plus 3x squared. So we're going to multiply the term by the power. So we're going to get plus 6 and then copy down x. And then we're going to subtract 1 from the power. So the power of x is just going to be 1. Repeat for the next term. So the next term, the power of x is just 1. So we're going to multiply minus 4x by its power, which is 1. So that's just going to give us minus 4. And then we can copy x down again. And then we're going to subtract 1 from the power. So 1 subtract 1 is just going to give us 0. Now, we're going to now differentiate a number term. There's no x in this term, it's just a number term. Now, when you differentiate a number term, you will always get 0, and I'm going to prove it to you now. You can rewrite any number term with x in it by just putting x to the power of 0 after it. So I can write that as plus 2 times x to the power of 0. Because remember, x to the power of 0 is 1, so plus 2 times 1 just gives you plus 2. So you can see now already that if we try to differentiate this term, we're going to be multiplying the term by the power of x. Well, the power of x is 0, so if I multiply this term by 0, well then all of it's just going to be 0. Okay. You could then subtract 1 from the power, and you could write 0x to the power of minus 1, but the fact that you're multiplying the term by 0 means you wipe it out completely. So that's useful to even learn at this stage. When you differentiate any number term, it just disappears completely. It no longer exists. So let's tidy it up. So we're going to be left with dy by dx is equal to 15x squared plus 6x Now x to the power of 0 here is just 1, so you're just going to be left with minus 4. Now, that is our answer. But just to confirm two important points, do you see the last two terms in the original curve, minus 4x and plus 2? When you differentiate any x term where the power of x is 1, you just take the x away and you're left with its coefficient. Do you see that? So the x term which had a power of 1, when you differentiate it, you just take the x away and you're left with its coefficient. And secondly, when you differentiate any number term with respect to x, it just disappears completely. You're left with nothing there. So we've successfully differentiated the curve in part A. So let's look at part B. Okay, so we have another curve here, and we want to differentiate, but there's a big problem. Unlike part A, we can't differentiate yet because there's roots in it. We've got to get rid of these roots. So we've got the square root here of x cubed, and we've got the fifth root here of x to the power of 6. So those roots have to go. The only way to get rid of roots is to rewrite them in index form. So you're going to rewrite them so that x has a fractional power. And the root that you take will always be the denominator of the fractional power, and then the power of x will be the numerator of the fractional power. So I'm going to rewrite it as 4 times x to the power of 3 over 2. And then copy down the subtraction, and we're going to have x to the power of 6 over 5. Okay, so that's really important. Get rid of the roots and rewrite in terms of fractional powers. Now, we've now got the green light to differentiate because there's no roots anymore, there's no brackets, and there are no x's on the denominator here. So let's go ahead and differentiate. So we put dy by dx down. Okay, so remember, to differentiate, you multiply the term by the power of x. So we're multiplying 3 over 2 by 4, so that's going to give us 12 over 2. I'll do cancelling later on. And then copy down x. And then subtract 1 from the power. So 3 over 2 subtract 1, so that's 1.5 subtract 1 is just going to leave us with a half. And then go to your next term, so we're going to multiply this term by its power, so that's going to give us minus 6 fifths, and then we've got x, and then we're going to subtract 1 from the power, so 6 fifths subtract 1, well that's just going to give us 1/5. And then tidy it up. So that's going to give us 12 divided by 2 is 6. So we're going to get 6x to the power of a half. And then we're subtracting 6 over 5 multiplied by x to the power of a fifth. Now, that's it. We've differentiated the curve. What you could also do at this stage is you could then go back and put it back in root form. So alternatively, you could then put your answer in root form. So we're going to have 6, and then x to the power of a half is just the square root of x, and then minus 6 fifths, and then x to the power of 1/5 is just the fifth root of x. Now, you might say, why are you putting it back in root form? Because later on in this module, or this particular chapter, we will then have to sub values of x in. So it's easier to sub values of x when you're working with roots than working with fractional powers. So please make sure that, once you've differentiated and you've got your fractional powers, try to put it back into root form again. Okay, so that is part B. Part C. Okay, part C, we want to differentiate this curve. Do you notice this time we've got x's on the denominator? We've got x's on the bottom line. Now that's a definite no-no. You can't differentiate until you get x's off the bottom line. Now there's a nice little quick method of doing this which is pretty pain-free. In order to get the x's off the bottom line, you just simply move them to the top line. So for example, there's an x in the bottom line. All I'm going to do is just slide that x up to the top line. But you can't just slide it to the top line because you'll alter its value. So to slide it to the top line, you have to change the sign of its power. That's what you have to give back. For the second term, I'm only sliding x. You only ever slide x to the top line. You don't slide numbers to the top line. So we're going to slide x squared to the top line. So when we do that, we're just going to then change the sign of its power. So let's do that first. So I'm going to slide this x to the top line. So it's going to be 2x to the power minus 1. So slide it to the top line, change the sign of its power. And then we've got minus 3 over 4. You see the way the 4 stays in the bottom line? We're only ever sliding x to the top. So slide x squared to the top line. It's going to be x to the power of minus 2. So change the sign of its power. That's the easiest, quickest way to do it. Now we're in a position to differentiate because all the x's are on the top line, there's no roots, and there's no brackets. So let's differentiate. So we signal our intent by putting dy by dx down. That means we are differentiating. And then let's do it. Let's differentiate. So take the first term, 2x to the power minus 1. You multiply that term by its power. So we're going to get minus 2. And then copy down x. And then we subtract 1 from the power. So the power is now going to become minus 2. And then go to our next term. We're going to multiply our next term by the power, which is negative 2. So we're multiplying a negative by a negative. So that's going to give us a positive. And then we're multiplying 3/4 by 2. So that's going to give us 6 over 4. And then we're going to copy down our x. And then we're going to subtract 1 from the power. So that's now going to become minus 3. Okay, let's tidy it up. So we're going to get minus 2 x to the power minus 2. And then 6 over 4 will cancel. Always cancel fractions down. So that's going to cancel to give us 3 over 2. And then we've got x to the power minus 3. Now, similarly, in the last example, do you see when you differentiated, you had fractional powers, and then I said, look, once you've differentiated and you've got fractional powers, put the roots back in. In the same way, I don't like negative powers in answers because, again, we're going to be subbing values of x in pretty soon, and it's not nice subbing a value of x in when the power is negative. It's not that it's impossible to do, but it just is just not nice looking to do. So what I want you to do after you differentiate, any negative powers that you have, you want to make them positive again. Now the only way to make them positive again is to slide x back to the bottom line. So if you take a look at this x to the power minus 2, we're going to slide x to the bottom line again in order to make its power positive. And we're going to do exactly the same here. X to the power minus 3. We're going to slide that to the bottom line again to make its power positive. So that's what you do. Anytime you want to change the sign of the power of x, you just slide x either to the top or the bottom. So minus 2 is going to stay on the top. And that's all going to be over x to the power of positive 2. And then we've got plus 3, it stays in the top. And then we've got 2 in the bottom. And we're going to slide x to the bottom line, so we're going to change the sign of its power. So it's going to become x cubed. And there we go, we have fully differentiated the curve in part C.